So welcome back to our modeling course Herrenkrug. So now you want to go into the modeling work itself. First general, I divided the modeling work into 4 steps. So step 1 and step 2 are optional. I provide you also the data with the folders 1, 2 and 3 so that you could also step into the third step, for example. Then you just use the already available ProMaIDes data files. So in the first step, so it's generation of GIS files. So this is pure GIS work, QGIS work. It has nothing to do with ProMaIDes, even nothing to do with the plugins for ProMaIDes. So it's GIS work. So the idea is here to generate shapefiles for the QGIS ProMaIDes plugins later. So in this stage, so here we apply then the QGIS plugins. So if you want to start here, you start with the data in folder 1, base data. The second step is then, I already mentioned it, to work with the GIS plugins, the ProMaIDes plugins, and you have also to work with the text editor. So what we will apply here is the QGIS plugins in the ProMaIDes toolbox, which is available in QGIS. We will generate text files defining the model for an QGIS or for an ProMaIDes import. And you can start here then in folder 2 with the QGIS data. The third step is then about the calculation, the work with ProMaIDes itself. So this is then your ProMaIDes work. So we import the model to the database, we calculate on the database, and we will put, or the output will go also to the database. And if you want to start here, so this is just ProMaIDes work, you can start in folder 3 with the ProMaIDes data. There are the data files already finished. And the last step, so this is then the results. There you will work with ProMaIDes, QGIS, or even ParaView, which is also a so-called ProMaIDes helper. Excel is also involved, we will see later. So there the idea is to display the data which was produced with the hydrodynamic calculation. And then you have to visualize it and you have to interpret it for your friend, to give your friend an advice if he should buy the house or not. About the working procedure itself, here a small link to our manual. There you will see also this graphic again. So this is more or less how to come from site-specific data to a result in our hydrodynamic model or in our ProMaIDes work. So what is objective? So first we have to set an instationary boundary condition as a point discharge here at the southern model boundary inside the diagram based on the discharge breach text. So here we will set a boundary condition. We will have to set our dike line, our 1D element, which you see here in the brown color. If you look to the two GIS data, there is already a dike line shape available. So if you start at the first step, then you have to produce this dike line shape. If not, you can use these available dike line shape. And we will this will based on the DGMV, because there we have a higher resolution. There you will really see the heights of the dike. Then we will produce two coupled 2D floodplanes, 100 times 100 meter, based on the DGM 100 LSR point TIFF. You see here already these two rasters. What you can do here, if you want to start in the second step, you can also use the ProMaIDes HUD raster exported shape. So there already these rectangles are available. You can import it to your plugin, and you should also use the bound cone shape just to have a look on it, what information are in, to set directly automatically the boundary conditions, these boundary conditions. We will also implement some observation points. Observation points are available to get additional hydrodynamic output. It's a bit like a guard station in your area, so you get additional information. Output files here. I set different observation points here in this area, but you can change this shapefile. This is given also here in the folder 2, the observation point shape. So you can edit it, or you can produce your own file. So this is on you, how intensive you want to work with the QGIS before. And finally, the results like maximum water depth you see here in blue, or arrival times. So it's always good to know how fast the flood is coming. You will get, and you will visualize in QGIS from the ProMaIDes database. Okay, to our first step, I go back, or no, I go in this direction. So this was our first step. So first we want to start with QGIS modeling work. So just working with QGIS. If you want to skip it, go directly to the next section. So QGIS is a user-friendly open source geographic information system. Why QGIS and ProMaIDes? You will find further information here in this link, and some general information, and also some links to some further web pages about QGIS you will find here in the general section. So what we have to do, generation of QGIS or of GIS files. So what we have to do, generate a point shape file as preparation of the observation point file. So what this shape needs is a text column with a name is required of each point, and please do not use any white spaces or special characters in the name, especially we in German like the Ü, S and so on. So don't use it, just use the normal characters, and don't use white space. Place the observation points in your area where you need further hydraulic information. For example, here at the Breitscheidstraße, I have already an observation point. And again, use one unique coordinate system. For example, I propose 25832 and set also your QGIS project coordinate system to this APSG code. Here's some help for QGIS. Just have a look. These are QGIS manual information. For example, how to create a layer. You can create a layer, a point shape layer for your observation points, and how you can add any features to your shapefile is also explained here. The result will be point shape file observation points. You can see it, you can also load it to your GIS system. It's also provided in folder 2, QGIS data. A second task is to generate a line shape file as preparation of the 1D element file, the dikeline file. So here also a text column with a name is required. And again, do not use white spaces, special characters. I already mentioned it. And the idea is place the vertices of the line, so the points of the line, really to the crest of the dike line, because later we will sample the heights from the DGMB. So our digital elevation model, we will sample the heights, and so we have to go with our points on the highest part of the dike crest. So finally, you have to go through the whole dike ring area, Herrenkrug. So multiple overlapping lines are possible. Please do, if you do it like this, if you do with multiple lines, then make a overlapping more than 100, I would say, or how you say, I would recommend at least 500 or 500 meter maximum overlapping of these dike lines. But you can also make 1 or 2 dike lines. It's also okay. So lines in your shapefile. Use a DGMB as a basis to see where is the dike line, because finally we will sample from these DGM. So, and what just a hint, you use a symbology for visualization. For example, go from 40 to 55 meters your symbology, and you will really see in a good way the diagram. You can also use the value tool. This is an extension for QGIS to see here. You see the value tool. Then you go, if you hover over these raster file, this TIFF file, the elevation. So it also can support your process. There's also the profile tool, also a nice extension in QGIS where you can read out profiles for a line. It is important that the files must be ordered. So decide, okay, I go in counterclockwise direction, for example, and then stay in counterclockwise direction, and do not exactly, and do not switch. So I think this is a good hint. Again, use here a unique coordinate system, and again some QGIS help. You find it here, how to create a layer, in this case a line layer, and how to add features to a shape. And the result you can also see in the folder 2 QGIS data in the diagline shape. So this is a result how it could look like. Okay, this was a QGIS work. Now to the second step of our, you see this, the first part was really pure QGIS work, but I think it's important that you get familiar with these two. In the second step, we use also QGIS, and we use especially the plugins which we wrote especially for the ProMaIDes setup. This we will show here. If you want to start here, then start with one QGIS data folder. Here you will find all which is required for it. Good. Some general information about our QGIS plugin ProMaIDes toolbox. Here the general information, setup of the ProMaIDes toolbox. Please use method 2. This is the most current code which you will get. And you will see here explanation of files which we will generate. So we will produce now from our site-specific data with the help of the plugins. We will generate text files, and these text files will finally, or in the third step, go to ProMaIDes, which will import this text file to the database, and then we will make all our calculation on the database itself. I propose to maintain a certain structure, generate the following files, which will come now in one folder. So also subfolder are possible, but do not make here one file and here one file. It's possible, you can do it, but I think later it will make it much more difficult to put all files together. Okay, first we will start to generate an observation point file. This is a text file. So how to do it? Here you have the link. The input is our observation point shape, which we produce. The output is obs point text, for example. You see here is our input. This is a shape file, and this is our output. It's a normal text file, and you can see it. You can explore it with the text editor. The explanation of the file, to know what is written in the file, you find here. So in a second step, we have to generate our 1D element file as a diagline. So you see it here. This is our line shape file. You see here our diaglines with our vertices points, and this is our output file, also again a text file. How to do it, you will find here. The base or the input data is our DGMV. We need it because we need the heights of the dike crest, and you can use the diagline shape which is available in the second folder, QGIS data. And the output is a diagline.txt, which is provided also in 3 ProMaIDes data. The explanation again you will find here. Good. Then generate a material file. This has nothing to do with QGIS. This is quite simple. How to do it? Copy an example file for a material file from, for example, this link. There you will find a file. This is available. So just copy it and then adjust it with the text editor, for example, to your purpose. What is written in the material file? It's about roughness, IDs, and so on. It is explained here, and the result is given in 3 ProMaIDes data roughness.text. You will find it here, and there's an example in. So this is a quite simple task. I also often recommend just take an example files also for other hydrodynamic modules. Take example files and then adjust it to your purpose. Then in the 4th task, we have to generate our boundary condition file, because we have a time series, an instationary boundary condition. How to do it, I again explain, recommend here, copy an example file from, for example, this link. Here is also explained what is written in. Adjust it with a text editor to your purpose, and use the provided time series. You see it here. Be aware that we divide this discharge over 3 elements. This is important. So you can't use 500. You have to divide it by 3. If not, you pump not 500 cubic meter per day. You pump 1,500 cubic meter per day per second. Sorry, into the area. Input is in the first folder, base data, discharge breach text, and the result, how it should look like, is a BC discharge .text in the 3rd folder. And finally, or the 5th step is to generate our 2D floodplain files, so our grids, and we can also produce here an ELM file, or at least a start of our ELM file. And the ELM file is a management file which put all files together. So how to do the grids is explained here in this link. Optional, use the provided polygon shape as basis for the grids. You can export it if you do your grid generation. So you can also import it again into your plugin, and then it's already available. Second, optionally use the provided polygon shape as a basis of the boundary condition. They are also provided here, boundary condition point shape. You can use it, have a look on it, and then just adjust it if you want to change your boundary condition. So input is the DGM100 LSR, which is provided. So this is a DEM, the digital elevation model for whole Saxony-Anhalt. We just use the part of the Herrenkrug. It's 100 times 100 meters, quite rough, but I think it's enough for this modeling course. And as an output, you will produce 3 files. So you will produce the raster1.text, raster2.text. We have 2 rasters. If you use this, then normally almost all is done. This you have to make an extra tick here to implement this, and think that you have to create also an ELM file. Then you will produce also an ELM file. Okay, and finally, so this was a QGIS plugin, and finally, again, we have to work a bit with the text editor. We have to put all these files which we produce together in our ELM file. The ELM file itself we produced here already with a tick here, with the activation here in this left corner. But still, not all information are in. So what is the ELM file? The management file is explained here, how all the things come together. Again, here some information about the text editors, and here some hints what you have to change in your ELM file. So you have to adjust or delete. You have to adjust or delete comments. So you have to adjust the number of time steps, because I think the default value is 12 or 24, but we want to run 288 hours, because again here we have a discharge boundary condition, at least 288 hours. So this we want to run. We have to adjust the material file. So we have to say where is the material file. We have to adjust the observation point file in the LM file. Where is the observation point file? The link or the path to the observation point file. We have to adjust the boundary condition file in raster 1. So where is the where the instationary boundary file? And we have adjust the 1D element file in raster 1 and 2. So the guideline file, there we have also to set the path. In general, if you have it in one folder, it is just / and the name of the data file. And the output is also given, finished output in 3 ProMaIDes data project ELM. Good. I think here I will make also again a short break. So this was about the QGIS work, working with pure QGIS and working with the QGIS plugins. And in the next step, we want to speak about the work with ProMaIDes.